Hello friends, today we are solving the first problem from the lead code, the problem number 1, that is the two-sum problem. First we will understand the problem, then we will try to identify the different solutions to that particular problem. Right, what is given in this particular problem? So it says that you have given a array that is treated as the nums, right, and you have given another target. Now you have to return the two indexes from this array so that the element at those particular locations sum up equal to the target value. And during solving that particular problem, you can definitely assume that there at least there exists a one solution. There exists exactly one solution in that particular problem statement. Right. So we will try to understand these inputs. Let me draw it here. Right. So first input you have given the nums, right, and here you are given the input 2, 7, 11, and the 15. Right. And let's write index as well 0, 1, 2, and the 3. The first target value, I'm representing it with the t, and it is given as a 9. So we have to find two elements from this particular array, those sum equal to the 9. Right. So yeah, we will look into the solution, but yeah, here you can clearly look into these two numbers are actually summing up to is equal to 9. So the output of this particular result will be an array that is having the 0 and the 1. Right. Let's take another input, that is the 3, 2, or the 4. So this element and this element is summing up is equal to the target value that is given as the 6, right? So you have in the output value, you won't return the 2 or 4. Instead, you return their index 0, 1, and the 2. So the output here will be the 1 and the 2, right? Let's consider the third one as well. So input is 3 and the 3. This is the array. Target value is again the 6. So here the 3 and the 3. So you can consider this 0 and the 1. 0 and the 1 is the output. So some of the things that you observed here. So here this particular element will be considered only one time. So you cannot consider one element multiple times, right? So that's the main thing you have to consider. Now we take one of these cases and we'll try to solve that particular problem. How we will solve it? And this is 2, 7, 11, and the 15. And you take two indices. First index you take the I. When I is at a particular index, then you will move all these elements. This is called the new solution as well, right? You will move your second index, that is known as the J, to from each location. Then you do that 2 plus 7 is equal to, in first 9, right? Here you will 11 and the 2, this is the 13. I'm doing it 17. Then next times your I will move here. So then in that particular scenario, your J will move in these two elements. Right. So when I'm tracking I is equal to 2, here I is equal to 7. In that particular case, you will write here 7 and 11, 18, and here the 22. Next time your I again move, I will move here, right? J will only be the 15. So in case of here, you write 11 plus 15, here the 26, right? But you don't need to iterate all these things. Once you find the result, so here's the result. So you, in that case, you will return from here and you don't need to compute these all outputs. Now we'll consider what is the time complexity of this particular solution. So you observe your I is moving on all the elements. You don't need to select the last element because this is a single, you don't have the another element to sum up. But yeah, at least you will move it for the n minus 1 times. And how about your G, right? First time it comes to considered, for example, n minus 1 elements, next time n minus 2, right? So for these n times, n minus 1 times, right? So first n minus 1, then n minus 2, 2, then n minus 3, and similarly. And whenever you sum up it, this is coming n minus 1 by 2. This is the overall complexity is the n square time complexity. Yeah. So is there a way so that we can optimize the time complexity? Yes. So let's look again. I'm just so we have 2, 7, 11, and the 15. Okay, I think this input is already being sorted input, but let's take if the input was given like 7, 11, 2, and the 15. Right. So some of the people can suggest, yeah, that is the very known problem. You can definitely do go ahead and can first sort this algorithm, then try to solve. But I think in that case the answer will be wrong. Why? Because the expected answer is the indices. So in this particular case, for example, 0, 1, 2, and the 3, so output should be 0 and the 2. But once you sort, the indices of the element got changed. So that answer won't be correct any longer. Right, now let's try to solve this particular problem. Right. Int I is equal to first iterate from the 0, and you have till where you have to iterate. You can iterate length minus till less than -1, but for now let's assume we take the last element as well, right? And here you can do for int j is equal to 0, j less than, yeah, do I need to iterate j from the 0? Again, if I iterate from the j, I can consider the same element again twice, right? So I have to always iterate whenever I have to iterate from the elements after that. So for that, I will change it to the I plus 1. Here it will remain the same, num start length, and here the j plus plus. Now you have the conditions. If your nums of I plus nums of j matches the target value, and in this case you will return the answer. And how you'll create the array here, like this, right? And here you will put your ij, this. Otherwise, again you will create an empty array here because the return type is array itself. So here we create the empty array and we'll do that. Let's try to run this particular code. Oh, there's a certain compilation error. Okay, I think I missed something here. I'm just trying it again. I hope it runs. Oh, sorry. This is a class, so we have to add a here the new keyword. That's what I missed. Yeah, so this answer is accepted. Yeah, thank you.